Okay, sorry. So the beginning is missing. So because of this dust, we have a problem, right? We have a problem, and this this dust, this kind of missing values or extra values, kind of accumulate, and we have um, we have to deal with it somehow. So in financial software, we can have money, disappearing on money being created, and that's unacceptable. Like if you balancing your accounts, they have to balance perfectly. That you cannot have money appearing somewhere and missing somewhere, right? In scientific computing, when you're doing scientific experiments or calculations, the errors will propagate, and then it will become impactful, because you may say, look, it's kind of insignificant, it's so small, and after so many decimal places that we kind of don't care. And that's true. In a lot of applications, we actually don't care. Like if you're calculating somebody, I don't know, tax, and you're calculating it, and there is like some very small sub fraction, sub or decimal kind of thing, the tax office says, yeah, don't worry, just round it up or down and to like 1 ore and it's okay. But if you're doing it for like millions of people, suddenly that matters, right? So for an individual, you can do this and that's okay, because your error will be like plus minus 1 ore. But if you're doing it for millions of people, your plus minus suddenly might be, thousands of krona, right? So you cannot do that. But for individual operations, sometimes we are fine with using floats, but we have to kind of remember that for some operations we cannot. It's the same in game physics. So if we're doing some placement or some calculations, what may happen is our object starts drifting or floating somewhere, because those errors will kind of accumulate, and suddenly our position kind of goes out of whack. Um, so it's the same in control systems, like when we're controlling robots or when we're controlling some medical devices is also important. So it is kind of a niche problem, but it is an important problem. And when you are given a task, you have to think, do I have to think about it or not? And if you have to think about it, then you have to address it. If you have a situation where it's like okay to have some imprecision, then you can sort of forget about it. But there are some best practices nevertheless. So for example, when you are doing equality check, if you're saying, is this float the same as the other float? You cannot really do that directly. You have to use some sort of precision ratio of saying, is that equality within that delta holding or not holding, right? And that's why we don't say, is A equals to B? We often say, is absolute value A minus B less than a certain threshold that I care about, right? If it is, I will consider A and B the same. But if it isn't, I will consider them different. So instead of doing direct comparison, we often do this. And then when you need to calculate something precisely, you don't use floats. You just use integers instead. And then when you're using integers, you have two options. You're either using ratios, like we did here, or you're using this notation where you agree that your integer represents a float, but where is the dot, you decide. Like you say, I have an integer and the last 4 digits is the digits after the decimal point, right? All right. So there is a missing slide. Let me check. So ay, 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 ay. That's the one. Okay. So let's go back. Yeah, so we had that. All right. So then there is this concept of a jar. So the jar is a kind of a accounting trick. So let's say we have a problem. Yeah, we have a problem here. So this is actually an example where you have to split $10 among three people, right? So how would you do that? So if we divide 10, you know, to three people, we have $3.33. But if we give three people $3.33, then there will be a 1 cent left, right? So then basically what should happen is two people will get 3.33 and the last person will get 3.34, such that the $10 is split, right? Because the sum after splitting needs to add up to $10. And we do that by keeping track of how much leftover we have after each operation. So we basically splitting $10 and we say, okay, the first person gets $3.33 and we have this 33. We're using a precision up to 4 decimal places here. And we have this sub-cent amount. So it's like 33% of 1 cent is left, right? It's less than 1 cent, but 33%. So the 33 is left. So we put the 33 into the jar and we say, okay, we gave the first person 333 and we have this reminder kind of in the jar. And then we do the second transaction and we give the second person 333. And then again, after the second transaction, there is a leftover and we add this leftover to the jar. And then we do the third transaction. And then after the third transaction, this is so close to 1 cent that we round it up. So after rounding it up, we give the third person 334, and then we have a leftover, which is missing money in the jar, which is this like one, because to round it up, we basically created this 0.001 to round it up, right? So it appears as if we kind of lost money because we have in the jar, we have like a missing leftover. Why is that missing leftover in the jar? Because we don't have the infinite sort of precision. Even if we're doing this accounting, we still are sort of not perfectly precise. So there is this sort of a small error that accumulates because of our precision of the jar accounting, right? Um, who understood that explanation? Okay. So we have 1 week. The task 01 is about this and about like doing a precise accounting. So kind of read about it and sort of think how this works, because you will use it for task 01 basically. All right, so that's about the precision. So now we're gonna go back and sort of learn a little bit about command line, and then we will start doing, after the break, we'll start doing some activities. So Bash first. So Bash was developed as a sort of the enhancement or a second generation of the shell, which was originally done by guy whose name was Bourne, and his shell was called Shell, and he did it in like late 70s. But then the guys who did Unix, they sort of thought it would be better to improve it, and they called they developed a new shell, which was called Born Again, kind of a pun again on the names because born sounds like being born again. So they sort of make a pun on the name. as you can see, those guys were sort of kind of cheeky about naming conventions. So it's the shell which still we using very frequently up to today. So the shell has been in use for 45 years. Do we have a better replacement for bash or for shell? Yeah, maybe. So for example, Mac, you can use bash on Macs, but you can also use what's called Z shell. There has been over the years multiple iterations of different shells. After bash, there was a C shell, which was using C language as a sort of the programming or scripting language for the shell. That didn't really work that great. Some people, like you probably notice, I'm using fish. Fish is sort of like an additional layer on the shell. It depends. Like it depends what you're using it for and like what is the main purpose of the shell. But Bash is pretty popular. When you're working with Unix and Linux, you will most likely using Bash. And then in the cloud course, you will use Bash a lot. So you probably know of or remember from the first year and from some courses, typical commands like print working directory, pwd, list, cd, and so on. So those are kind of a useful commands just to refresh. Cut kind of prints the file. So cut is quite useful. You can sort of, for example, cut command line. So I have this markdown file here, and I can say cut and print it, and then it just dumps everything to the screen or to the standard output. And then you can pipe it with something, right? So I can cut this file and say word count lines, how many lines this has, and this file has 1200 lines, okay? So the other command which is useful is the reverse of cat, which is called tac. And if you say tac, yeah, I don't have it here, but in Unix or in Bash, you should have it, and it's the same as cat, but it prints the file backwards. So if you are printing a log file and you only want to see the last couple of lines, then you can sort of do tac instead of cat, and then you will see it kind of in the reverse order. If you want to see, so if I do cat, it kind of dumps everything, and I only see kind of the end of the file. So what if I want to see the beginning? Well, you can pipe it with less, right? So if you pipe it with less, then it starts printing the file and then it stops and waits for your commands. It's sort of like a line editor, which allows you to search for something or allows you to navigate the file. So for example, I can type this bank and say questions, and it will kind of jump to that line which has questions in the file, right? So, yep. And then you can quit by Q. So those are the basic ones. I kind of related to cut, and echo is like printing. So then you can combine them. As I showed you, you can kind of combine multiple commands, because all of them, what all of them are doing is printing stuff to the standard output. And then you can navigate that standard output through this bank operator, the pipe, into something else. So for example, I can print the current folder, grep all the files, all the lines to check if they are text files, and then count how many I have, right? So you can kind of create a very useful, fast scripts to see, okay, how many text files do I have in this folder, or how many text files contain something, and things like that. So ls is like listing the folders in the current folder or directory. The pipe operator, grep is grep has been developed to extend this kind of command line editor, with pattern matching capabilities, and it's very powerful in searching for things. So if you, for example, want to check in which files in your project there are to-do items. You would use find and grep, and then it will kind of show you which files have certain to-do elements, right? If you're working with IDE, you can probably do that with IDE, like with the mouse, but often it's much faster if you sort of don't use the GUI tools. It's sort of more effective and efficient if you're using command line, if you're working with large projects. And often you have to work on the server, and then you SSH to the server, and then text is all you get. You don't get GUI. So then, like, knowing those things and being able to do certain tasks like by command line makes you sort of like a power user. All right, so pipes, I think it's quite intuitive. You've used pipes before, right? And yeah. So then echo is useful with the operator, like a redirect operator. So as I said, all those tools do, they print stuff. They print the result to the standard output. But sometimes what you want is you want to redirect it to a file. And then you have those two options. You can redirect it as an append to a file, or you can kind of create a new file. So if you use the single one, you sort of create a completely empty file, and then you redirect what you're doing to that file. And then if you use the double one, you sort of append at the end. Those are for Bash. Similar redirects work in command line tool in Windows, but you have to use, the notation is a little bit different. So you would have to check if you're not using Linux subsystem on Windows, you would have to check what those look like. They have a little bit, the PowerShell has those, but the syntax is a little bit different. And then you can redirect it backwards. So you can, for example, say, take data from this file, pipe it into the sort command, and then whatever sort does, pipe it into sorted, right? So if you have a list of numbers and you pipe it to sort and then pipe it to a different file, then you will get the same list of numbers, but sorted, right? So sort is another command line tool, which is useful. So here, for example, we checking how and what kind of CSV files we have in the current folder, and then we listing all those files into CSV files text file, right? By this redirect. Nothing fancy, kind of very straightforward. So ls has some options, and command line tools often have a notation which allows you to specify some parameters or specify some things. And they usually have a single dash with a letter, some sort of letter, or short combination of letters, or double dashes with more human readable kind of name. And this is called long, and this is called short. So this is like a convention which comes back from the Unix days, where you have those long and short options or parameters that you can pass to your command line tools. So ls, as you can see, is quite comprehensive. Most of them kind of make sense, and you like once you use them like few times, you will remember. So L is like a long version. If you don't have L, it's like a short version, right? A is for everything, or the hidden files which are dot at the beginning, don't include it. H usually means like human readable sizes and kind of notations. So you can use it for checking the size of your files if you want kind of a more human readable postfixes. And then you have R usually is for the reverse, and then you can combine multiple letters into a single dash to have a combination of them. So you can say A, L, and H, and then it will be like all files, long format, human readable. It's sort of like if you're starting with it, it may say, oh yeah, it's kind of so complicated, but it's not really. Like you kind of most of them, like the guys who designed it, they kind of make it somewhat intuitive. And then you have man pages. So if you forgot what are the commands, for example, for human readable ls kind of option, you can say man, which stands for manual page, and then you get the description, right? Nothing fancy. The fancy part about man is that it uses the same kind of a line editor that less is using. So if you man something, so if I man, yeah, let's man, and then you can see I'm kind of all the commands and all the command line things work exactly the same as with less. So I can jump, like if I'm looking for something. So let's say, let's quit this. And let's do man ls. And then I'm looking for this human readable. So human is not really. So what is age described like? Let's see. Let's search for -h. When used with L option, suffixes, kilobytes. Right, so it doesn't use the word human for the -h. Yeah, so it's a bit of a hit and miss sometimes. Anyway, you get the idea, right? So you can kind of search and jump to a line that you want quite easily. And then there is grep. Grep is really really powerful, really useful, and it has a number of those extensions as well. But the default pattern is super simple. The default pattern is grep, a pattern, and then if you don't do anything, grep will expect stuff to come from the standard input. If you specify the file, it will kind of do the file. And then if you specify R, and the folder, it will recursively do for all the files in that folder, right? So then there is some additional things like being case insensitive, showing the line numbers and inverting the match, and then counting the lines. Those are the most popular ones and the most I remember and I use often. And those are kind of good to memorize because they come handy for working with grep. And then we can, for example, do something like this. And what it means is we have some log file and we're checking which lines have error in the log file. So it goes line by line. And then if there is an error, but there is debug also, then it excludes it. So it basically lists us only the error entries in our log, which were not debug errors, right? So that's why we use the inverse, because we say, okay, everything that has error and debug, it's fine, but everything that has error but doesn't have debug, we should see, right? So this is like, it is kind of like solving a puzzle, because you have a certain task, and then you have to organize it into those like small subtasks and put it all together. So it's kind of like, solving a small programming task or small problem. Find is another one. It basically allows you to filter files that fit certain criteria. So you can use find to browse your repository and check how many Go files I have, or how many files have certain properties. So you can search by the name, and then you can have a pattern. You can search by type, and then by some other things like sizes and things like that. So you can, again, it's kind of a very powerful tool to work with code bases and code repositories, because it allows you to quickly navigate, what you want to find, or what you get some statistics. BC is awesome. BC stands for Basic Calculator. Again, it was designed in the very early days of Unix. And every time I have to do something with finances, I always use BC, even today. I honestly don't really trust Excel. And I got burned by Excel doing some operations because of the rounding errors. And BC does not have rounding errors. It has a fixed precision calculations, and it always gives you the exact, notation. And you can, you basically set how many decimal places you care about, and you can use arbitrary length here, and it will always do all the calculations perfectly, correctly to that precision. So you can, of course, pipe BC with other tools and feed some calculations to BC as well. And then you have no floating point errors ever because BC is super nice. Okay, and then one more, ed. So when I was a student, I had a teacher who made us use ed, and it was pain in the ass, like honestly. It's a very primitive editor. You have to memorize a lot of those cryptic kind of ways of dealing with the file. It's super powerful and super powerful, and it does not require a lot of bandwidth. So it's very speed efficient, and it works really well with slow connections. So for example, you have to connect, if you have to connect to something like on Mars, and you have like 20 seconds delay every time you press a key, then you don't want to use GUI, right? You want to use something like this, right? But it's not often that you will use it, right? So it's very kind of a hardcore way of doing editing of files, but it still exists, and it still is, it is used. I don't use it. I didn't use it for like 20 years, but recently I was using Claude agent and for like coding, and Claude is using ed. So I realized Claude agent is using ed to do certain editing of files because it allows it to jump to a line of code and insert certain things using ed, right? So why I'm talking about it? Because we sometimes build tools for other programmers. So we often build applications for end users. That's kind of the majority of the pyramid, like at the bottom. We do CRUD applications for some businesses or some customers. But if you kind of navigate yourself over the pyramid, we kind of build tools for other programmers. And we also build tools to work with AI for other programmers and so on. And then if you're doing that, you may find that actually using ed for whatever you need to do is the perfect solution. It's a perfect tool for the job, right? So every time like you have a task where you have to, for example, modify a text file in place, like you have a text file, let's say you have a form, and then you have to in place inject some data into that file. Ed would be the perfect tool for the job. And you can automate it and you can script it such that ed is doing what you need to do, right? Instead of you programming all this logic and everything like in C++ from scratch. Like we try not to build stuff from scratch. We try to reuse what's there. So that's why I'm telling you about ed, because in modern times where we will be building tools a lot, not for end users, but somewhere in between end users and AIs, ed might come really handy. So for those of you who are kind of interested, you can check it. But as I said, I personally didn't use it for like 20 years. And I don't think you should learn it, but I think you should be aware of it. And then maybe if you're building a tool that needs to do this file editing, you can tell AI to use ed for you, right? All right, so structured data formats, why we use them. Those are super we will have to have a break before I end up the slides because I can see I have still a lot of slides and are we getting close to the break time? But let me finish about the CSVs. So you have database course right now, right? You didn't have a database course before. So so far when we talked about find and like grep, we talked about like unstructured files. So if I kind of do ls, I have kind of a list. So it lists me the files that I have in a current folder. And if I say all long and so on, it kind of prints me like, okay, there is like some sort of permissions, there is some sort of inode indicator, and then some other things organized in columns. And then the last column is like the actual file name. And then I have some date. And this is all sort of like space separated. And for human, it is very nice. It sort of looks like a table. But for computer, for processing it, it's kind of tedious. Like you would have to do a lot of thinking and a lot of processing to, for example, extract the timestamp of this, right? But you can see it has this sort of a columnar, like table-like structure. So this table-like structure is super useful if we could have something other than space delimiting our entries, right? Because you can see like this thing is delimited from this thing by space, but January is also delimited by the day of January, right? So the space is not a perfect delimiter because it's often used as some kind of a like, the space here actually means it's the 13th of January, right? So that thing is one thing. It's not two things. It's like, it's a date, but it uses the space. And I have space delimiting other things, and then it's confusing. So not using space as a delimiter is kind of useful. And that's why we often use comma as a delimiter, because if I could inject comma between the things that I have here, I would have a nicely organized columns of what I'm dealing with, right? So comma-separated files were invented very quickly because the guys or girls who were programming stuff to process this kind of command line tools, they realized it's so much easier if I know what the delimiter is and if the delimiter is something else than space. So it's very human readable, very plain text, very super easy to work with. It's supported by everything, like all the tools, Excel, your AI tools, data pipelines, they all will support it. And they are very lightweight because there is no extra like XML or JSON overheads, right? The overhead is often useful because we often don't want it to be super human readable. We want it to be more machine readable, but there is always a balance between this sort of plain text or kind of XML JSON, and it's super friendly for data processing. And if you having a database course, you will talk about SQL tables, and the SQL tables are basically like a binary management system for comma-separated value files. Like it's like basically the same thing, but kind of to the next level of abstraction. You can do joins and you can do kind of much more powerful things. But at the end of the day, if you dump your SQL table, it is kind of like a CSV file, right? So for spreadsheets, for data input export, and for log files, sensors data, database dumps, we use it everywhere. So today we're gonna practice a little bit, and we're gonna use it. So we will use this structure where we have some form of ID, name, surname, sex indicator by the letter F or M, female or male, and then age, height, and salary. So this is like an example CSV file where the first line indicates what is what. It's called metadata. So it's not actually data, it's like data about data. And then we have line by line the actual data, right? Okay, so you can see that tab separated file would look the same, but instead of comma, we will use a tabulation to indicate what belongs to what. So first line often contains headers, and then each line is a data line. And then it's super easy to process it with awk, grep, or other command line tools. What happens if we have missing data? So what happens if for one entry we don't have the age? Then it will be empty, like it will be comma, comma, and then the next value, right? So the value would be empty. So we have to deal with that somehow, right? Often when you process a data file and the data is missing, when you're reading it, you will kind of read nothing. Like there is nothing there. There is nothing between this comma and this comma. So, there is no value. So if it's an age, you have to deal with it. You can use, depending what you're doing, like you can ignore it. You can ignore that particular row if you're calculating like an average or sum. Or if you're doing some machine learning training or something, you have to like inject some dummy data, right? So let's say you're doing some machine learning task, and then you have a data related to age, and for some people, age is missing. What would be reasonable to do? Would be reasonable to assume the value is 0? Not at all, right? Because we don't have like humans with age 0, and then if you're doing training, then that makes no sense, right? So what people typically do, they either ignore it, like they cut it out completely, so they don't use it as an entry for training, or they use an average. Because if you inject some data which is an average, then it sort of has no real significance to that training, right? The average gets a little bit emphasized, right? You should not use minimum or maximum, and you should not use, definitely not use 0, or some like value like -1 or something, right? That would make even less sense. So it depends what you're doing. All right, so then oak. So I will talk about oak after the break. Let's have a 7 minutes break. And then after this, we will do the tasks. Record, or maybe I should set up like a reminder myself on the phone. Yeah, sorry, I forgot to press record again at the beginning. So the beginning is cut. We talked about oak, and we went through the oak slides from section 6. So sorry for online people watching it afterwards. Okay, so oak and floating point numbers. It basically uses floats. So because the tool uses floats, it will accumulate errors if you allow it. So if you, for example, say print, 0.1 plus 0.2, it will use them as floating point numbers. And then it will basically do one float plus one float, and it will have this sort of error at the end, this inconsistency, right? So also, if you do some equality check, it will say, no, this one is not the same as this one because of inconsistencies, right, of the floating point representations. So it will print not equal. We learned already not to use equality check for floats, so that's not surprising. And then if we do repeated additions, so for example, if I add 0.1 10 times, then I will not get 1 at the end. I will get 1 with some error. So we have to remember that oak is like C or C++, is the same. It's like floating point representation, so we have a problem. So if we if we want to do proper oak calculations, we have to use GNU oak, and with GNU oak we have to use the M delimiter, which forces oak to use the integer calculations for high precision mathematical operations. Interestingly enough, I was playing with it last week, and on Mac, so I will show you. So on Mac, if I make it bigger. So on Linux, it works as it says on the slides, but on Mac, I have, if I say man, so yeah, you can demonstrate it yourself. Like you can print it, and then it will actually have an error, even if you're using the -m. So if you say, tell me about -m. Okay, it says yes. If you use -m, it forces arbitrary precision arithmetic odd numbers. And this option is not does not have effect if Go is not compiled with the high precision, like arbitrary precision arithmetic. There is a note. You see the note? So the maintainer of Gowk kind of left. And this feature is on parole, which means that feature may misbehave. And on my current version and on the version I have on my system, it is misbehaving. It is not actually doing what it's supposed to do. So, you know, bugs happen, even if you have kind of good intentions. And even if things should work as described, sometimes they don't because the maintainer is not longer there, which is kind of quite interesting. The thing is with Oak, I never really were doing mathematical calculations with Oak before. I was doing it for only data transformations, and I was using BC for arbitrary math calculations. And you can do the same. So you can pipe Oak with BC and do the calculations with BC because then you have a guarantee that it will work. So in theory, you know, there is the option for arbitrary precision math in Oak, but you don't typically have to use it. And if you do have to use it, you have to check if your system really supports it. Okay, so we talked about this already, about the equality check. And the correct way is with the kind of error, like with the epsilon. You know, I showed you this absolute value. So ups between A minus B, instead of using ups, because Oak does not have the absolute value function. It has a square root. So what we can do is we can do the minus, take it to the power of 2 and then do a square root. And that is basically doing the absolute value, like it will convert a negative to a positive. So it's sort of like a trick that you can do if you don't have the apps function. And then, yeah, if you want to, if you don't like, is that nice to do the absolute value using the square root and power of? Not really. Like you're using a lot of computing to do something that should be like very trivial. So then you can do the apps using this notation in Oak as well. Like it's the same as the question mark operator in C. So you have the condition, and then you have the true branch and false branch, and then you basically, depending on the condition, you're subtracting from the larger number the smaller number, right? So that simulates the absolute function. Yeah, so it's kind of up to you. This one is okay, but should not be used like it, the code smells. It like uses too much computing for the task at hand. All right, and then we have kind of a lot of practical examples. I'm not gonna go through the examples because you can go through them yourself because of the task. So you can check the examples. If you find like an example that matches the task, you can just use it. I just kind of show you two. So for example, for counting females in the data file, we basically have to say, okay, we have to use the comma as a delimiter, and then we have to restrict the first row, right? What often happens, that is typing this over and over again, if you have to do multiple things on the file, is actually pain in the ass, right? You have this first row, which is the metadata. So what I typically do, I keep my CSV file originally with the metadata, and then I copy it to a separate file, and I delete that row completely. And then I don't have to do this ever again because I only have data file, right? And I know what the data is because I kept the original with the metadata separate. You probably can do the same. So if you don't, you have to ignore the first row because the first row does not have, like you cannot do stuff with the column number 4 because instead of F over there, there is like a description of what the column is. And then let's say you're counting what is not female, and then the first row will not have F there, but it will not have M, and you will count it as something, and you should ignore it because it's not a part of the data. So the first row is a kind of, yeah, it needs to be ignored. And then we're basically doing the counting. As you can see here, we did not initialize count. We did not say begin count equals 0 because the variables will initialize to default values automatically in Oak. So we don't need to declare them and we don't need to initialize them. Count will be declared and initialized to 0 to start with, and then you can just say count plus plus. So it's like a very trivial syntax for doing trivial operations. Okay, and there is a bit more complicated thing, like find the person with the highest salary. And then what we have to do is we have to like iterate over all the lines. We have to keep track of what the current largest salary is and check if the current salary from that line is bigger than the one we kind of keep track of, right? So we have to have a variable storing the currently largest salary and then checking if the current line salary is bigger than the one we're storing, right? So, and we also have to check if the salary is not empty, because if the salary is empty, we'll have like, it will throw, right? It will kind of, so we ignoring the first row and we checking if the salary is not empty, and we checking if the current line salary field is bigger than our current max. The initially max will be 0 because it's a variable initialized to initial value, which will be 0. So that means, is the first row salary bigger than 0? Yes, it is. Then we say, okay, then max equals the one from the first row, right? And then we keep track of the ID, name, and surname. And then this will happen line by line. So if there is another line where the salary is bigger, it will be replaced. All those fields will be replaced here. And then at the end, we print the result, right? Super trivial, super simple. You don't need to write C program for it. It is kind of like looks almost like a pseudocode, but it is actually code, right? It's like a script which is a one-liner. You can type it as a one-liner, but often for those more complex scripts, one-liners are a little bit cumbersome, so you can actually store it as a separate file and say, oh, use this script file and this data file for my processing, right? So you can do that with Oak. So I will show you how to do that if you have Oak file. So like count females, we have exactly the same as before. We're saying, okay, separator is comma, count equals to 0. We do the counting and we printing, and then we say dash small f, which means use this file as a script file and use this file as the data file, right? All right, that's it. So if we go now to task, how are we doing? We probably should have a break. But after the break, if you go to task 00, you will see that you should use no AI for it. You should use your head, you should use the slides, and you should use the man pages. And you will do two things. You will do a CSV data analysis, for which you will use the test and test 1 million files. And then you will use the that aux file, this one. You will download it, unzip it. Oh yeah, so about the TGZ. So TGZ stands for tar gzip. GNU zip is like a free source, open source representation of the zip compression. And tar is like a program that packs a folder structure into a single file such that you can unpack it into a folder structure. So TGZ means there is a folder which has been packed into a single file, and that single file, the tar file, has been zipped. So now you have to unzip it and untar it, okay? I can give you the commands how to do it right here, but you can look it up on the internet if you need to. So for creating a tar file, you say tar create file, and then you specify the name with the tar extension, and then you specify folder which needs to be tarred. So C stands for create and F stands for file. So it's like super trivial. If you want to see what it's doing, you say, okay, show me verbose what you are doing. And then if you want this to be zipped on the fly, you say and zip it on the fly. And then instead of tar, you would say tar gzip. So this is for creating a zip of the folder as a single file. And then to unzip it, you say tar, and then you say extract file, which was zipped, and show me what you're doing. And then you say xtgz as an input, and then it will kind of unzip it in the current folder where you are. So it will kind of, the V like shows you like line by line, file by file, what's doing. You can skip this one if you don't want to see the whole structure, or you can use it if you're not kind of confident what's doing. And then C is for create, X is for extract. So again, nothing super fancy, but if you need to remember those commands, you can like look it up. So for unzipping the this git tgz file, once you have it, put it into a folder where you want the whole thing to be unzipped, and say tar xfz and then the name, and it will kind of create the folder structure for you. All right, any questions? There might be questions. So we have assistants. We have a very good students and helpers, which you can ask for help. And can you introduce yourself, guys? And you can speak with them fluently Norwegian as well. So.
Yes, my name is Axel. I'm going the third year in natural programming. Some of you probably know me from last year when I was teaching assistant in software security. I'm currently writing my bachelor's, and I'm looking forward to the semester.
I'm Nikolai. You might recognize me as well. Yeah, I'm also a third year student writing my bachelor's with Axel. And hopefully we can help you.
Great. So I'm here as well. I will answer questions. Organize yourself into kind of groups, like maybe up to 4 people. Such that it's not too crowded. Like we have, one person alone. So maybe some people can join this room, this table. So we don't have like 2 crowded tables. And then try to be like 3-4 people, and then try to do this. So what you need to do is specify it in the task 00, and you clone the whole project. You clone the whole project file structure into your local laptop using Git. Who is familiar with Git? Everybody? Those who are not so familiar, ask the people who are familiar, or ask the TAs, and really get familiar with Git. We will use Git a lot. So once you clone it, you will have access to all those files, and then you will have access to this task. And this task is a markdown file where you have the tasks, and then you have a space of where you need to put something in. So you have to do something, and then you usually have to put in the script that you've used and some counts, like how many females they were and how many males they were and things like that. And then once you create that file, you will commit it under task 00 into your personal space, which I will create now. So by the end of this session, what you will do is you will commit what you've done and how much you went through as a group, but all of you have to do it individually. So the Git commands are individual, the work is group work, and then the submission, like everyone needs to individually submit what they've done into the Git repository. Okay? Into the personal workspace. The personal workspace is completely empty. So what it means, you will have to create a project called task_00 first, and then initialize the Git repository for yourself, and then put the new file in there, right? So there is a little bit of a Git and GitLab work related to the management of the answers. So I hope it is clear. But if it is not clear, we can kind of clarify it. So what I will do now, I will double check and generate all the personal workspaces for you. I will publish where they are on the wiki. You will find it. You will go there. You will create a project for yourself called task00. And then you will initialize the Git repo for that project. It's done like using GUI, like directly in the GitLab. And then you will clone that to your local laptop. And then you will have two copies. You will have the copy of the course, GitLab, Git repository, and the new one. And then you will copy the file called task00 from here to here. You will work on it, fill in the stuff, and then commit to your own personal repository. Who understood this? Great. So at least one person in each group understood. So that's great. So I hope we will be okay. If there are problems or questions, then ask. I will not record any further discussions, and the online people can work together, like you guys can chat and work together also. And make sure that everybody who is listening to me and everybody in the room has so far clicked the request access thingy to the course. And that's it. So let's have some fun with awk, grep, and find. Some tasks, the initial tasks are for the CSV file, and then the remaining tasks for section 2, there is a section 2, is about the Git repository. So for this one, the first one, we will use a lot of awk. For the second one, we will use find and grep mostly. Yeah. Okay, have fun. Yes? Okay, yeah, you can talk with the TAs.
Is it mandatory?
Because I have a friend who's back at home who took a wisdom tooth,
Right.
and I want to tell him if it's mandatory.
So the 0 is not mandatory. At the end of today, I will also talk about 01, and 01 is already mandatory. So, but the deadline for 01 is the next week, so he should be fine. Yeah.
Okay.
So he can skip 00. Yeah. Yeah. Hi.
I just can't see my name.
You can see your name?
No, I can't.
Okay.
So I can see everything,
Yeah. So let me.
but not my name.
Okay. So let's do this. Let's go to the top level. And let's see. Yeah, you just need to click here, and then I will let you. Yeah,
Thank you.
you're welcome. I don't know, for some students, the button is missing. I don't know why. Yeah. Do you want to work alone or do you want to join other people?
Right now.
Okay.
So I can.
Okay. So, So I'm recording, but I did not unmute myself, so not going well this recording of the lectures. So I will start one more time. If you go to the wiki and go to the top level wiki, there is a link to workspaces, and then you have to find yourself, which is this link with your username. And then once you go to that username, you are the owner of that subgroup. You can create projects, you can create subgroups, you can do whatever you want. And I have written up that there are two options. You can create a project per task. So you kind of go here and you say, okay, new project, task 00, and then you keep your files in that task 00. And then for task 01, you come back to your top level and create a new project called task 01. That's one way of doing it. And you will have a single Git repository per task. So if we have 13 weeks and you do 13 weeks of labs, you will have 13 projects, right? It is a little bit tedious, so you will have to manage 13 Git repositories, okay? If you are on a lazy side, what you can do is you can say, create a project, tasks, and then you have just one repository, and then in that one repository, you create a folder called task 00, task 01, and then you have 13 folders, but you have just one repo, right? One Git repo. More kind of lazy and more convenient. There is a catch. The catch is that you will have to share your code with other students. And even though currently you can make the project private and nobody can see your code and cannot see your tasks, you will have to share some of the tasks with other students to get feedback. So if you pack everything to a single Git repo, you'll have to open it, make it internal, and be visible to everybody. So then everybody will see what you've done in that one single repo, right? So if let's say task 03 is to be reviewed, your task 00, task 01, and task 07 will also be visible because you have to open it up. So if you are privacy conscious that you don't want to share other tasks with students that don't require peer review, you have to create project per task, because then you just open up that one single project. If you have a single project for everything, you will have to share it with other students, and then you may not want to do that. So it's up to you. But it is a little bit more convenient having one repo instead of multiple repos. But that's your decision how to organize it. Who understood what I just said? Okay, great. So those who kind of need to catch up can ask the other students. And then I don't really care. Not everything will be reviewed. Task 00 is not reviewed. Task 01 is not reviewed. Task 02 will be reviewed. So, but you're not gonna lose much showing other people what you've done because we go sequentially, right? So if let's say task 03 is reviewed and you show them what you've done for task 01, it doesn't matter because it's already gone and ticked and blah, blah, blah. So the privacy thing is more about like your feeling rather than pragmatic of hiding something that other students can use to cheat because they cannot really use your work later anyway. And then when I was a student, it was quite interesting because I was doing a master's degree in UK. I was doing advanced computer science in UK. And I came from Poland where everything was secretive and we sort of didn't show to anybody what we were doing. And in UK, in the first class, our supervisor, he said, okay, you're gonna get an account on the shared servers. Each of you will have an account. You have to make your folder, your personal folder on that server public. So everybody can see what you have on your folder, how you writing your scripts and how you writing the solutions. That was the rule, that everything has to be public so other people can learn and look how you're organizing yourself, how you writing your scripts and so on. I was like, really? Like, yes, really. And for a year in UK, basically, I was actually browsing other students, like other colleagues' folders to see how they were doing stuff. And it was quite fun. So, you know, I cannot enforce this. We have the privacy laws and it's up to you, but you can make the decision yourself. So if you want, you can keep everything in one project and then share it. If you don't want, you will only share some projects that we will require to be shared because of the peer review. All right. Yeah, that's it. So carry on. Those who need assistance with GitLab, you can ask now as well how to create this and how to organize it. And as you said, once you have the Git, you kind of have to manually copy a file, the MD file from the task to that new repo and add it to the new repo such that we're losing the linkage. We kind of do it on purpose such that we don't track the original task file with here. We could do pull requests and kind of make the link kind of explicit, but it's too much work and it would be too much mess. We tried to do a little bit like this last year and it was like just a nightmare. So I think breaking the link is sort of better, and we basically just manually copy the file to your new folder and manage your own Git repositories yourself. And there will be no link to the to the project of the course. Does it make sense? Like Git wise? Yeah, okay. So for task 00, you do have to submit what you've done today by 12. I don't care. You can continue working on it if you want to learn more about Oak, but it's not required. I only want you to do this workflow, to kind of commit stuff into the Git repository that everybody knows how to do it and everybody does it. If you did not complete all the tasks from task 00, it's okay. Just commit by 12 o'clock what you've done. There is no problem not completing everything. As I said, the purpose is not complete everything. The purpose is to test that the workflow works, that you have a workspace, and then you know Git and how to manage your projects. Task 01 is compulsory. You have to do it. But task 00 is not compulsory, so just do what's there. If you not do it, that's okay as well, but I prefer everybody doing it because that indicates that you sort of know what is required for the compulsory one, which is 01. All right. So it seems our rule that we stop at 12 may not work because maybe some people will have problems like pushing to their repos and stuff like that. So let's for today, like just push afterwards. If you cannot push by 12, that's okay, no problem. So try to do as much as you can and then try to push. If it doesn't work and you have to go home, then like push at home, okay? So that's for task 00. About task 01. So I cannot tell you everything because if I tell you everything that I already told you and then you cannot think, okay? So let's say you're solving a chess puzzle and it says made in 1. I already told you there is made in 1, right? But if I tell you solve the chess puzzle and I didn't tell you it's made in 1, you don't know if it's made in 1 or made in 2 or made in 3, okay? So for some of the tasks, I cannot tell you everything because then I'm giving you away the ability to think and kind of solve the task, right? But it annoys students. So I tried it like 3 years ago and then students were really angry that I didn't tell them something and then they say it's unfair. So I'm telling you now that I'm not telling you everything, right? So in task 01, there is a task and you have to read the task and you have to solve it. But not everything is spelled out in the task. You have to think, and there is no perfect answer, but you have to think what decisions you're making and what assumptions you're making, because not everything is in the task, okay? We will come back to task 1. We will be doing it for 3 consecutive weeks. So task 01 is something that we start next week, and then we will carry over a little bit more in the next weeks. So don't worry if you don't solve it perfectly. Again, it's not about solving it perfectly. It's about thinking and kind of, trying it. And task 1 is about C++. But because you're learning Golang, and because you have to learn Golang for cloud, if you want to do it in Golang, you can do it in Golang as well. So as a practice, because the task 01 is quite simple, you can use Golang instead of C++, okay? So that's all about task 1, and we will talk more about task 1 next week.